Just one moment, please. Okay, I think Amanda, you may need to help with this one.
I can check. I thought this meeting was taken over by Virendra.
Yeah, Amanda and Virendra, would you help me with this one? Meeting info does not allow me to change the setting.
Virendra, would you jump in? You can help with this one. Please turn off the recording. Okay, go ahead. Yes.
Hi, Sam.
Thank you so much. Then I'm Sam Chang. I'm Dean of School of Technology and Computing. I may not stay here longer, but I truly appreciate. Have a wonderful time for our student and yourself. Thank you.
I'm honored that you showed up for the beginning of it. It's good to see your face as well.
Yes, thank you. Thank you.
I think you should be able to present.
Okay, let's start this. And just go ahead and let me know when you can see the screen.
Yes.
Excellent. So I'm titling this presentation, Accurate Reconnaissance. In cybersecurity, there is something called the kill chain, and it was released by Lockheed Martin, a defense provider, in 2011, and it details 7 steps to a cyber attack. And those 7 steps are basically how the malicious attack invades an organization's computing network. And the security team can stop the attack at any of those 7 stages of the kill chain. And so the very first stage is reconnaissance, when the malicious software is looking for that foothold to get into the organization's network. And so accurate reconnaissance is the first step that you can detect malicious software and stop it from invading the network. And so some of the work that I'm involved in with machine learning and artificial intelligence is being able to detect malicious activity using machine learning and artificial intelligence through behavioral analysis. Now, why hasn't machine learning and artificial intelligence been successful in cybersecurity to date? It's been in use, 80 years for various things. So we're going to talk about that. I want you to think about that. Let's go to the first slide. And right before COVID hit, the month before COVID hit, I was up in Canada, in Victoria on Vancouver Island teaching. And this actually happened. People started getting these alerts from Scotiabank. And I'm actually teaching incident response with a member of the Canadian cyber defense team. And so, we grabbed this. This was a perfect example of, an incident that was designed to get people to click on a link. And, this came through mobile phones, and people had accounts, banking accounts at Scotiabank. And so as you can see, some people are well trained not to click on the links, but if you have a Scotiabank account and you see this, your instinct, especially if you're overwhelmed and working hard, might be just to click on it. And that's what they're counting on. And so that's where I put for the introduction a scenario where you've stayed late at work and you're just about to leave and you see this alert. You click on it, you notify the network manager because you realize it doesn't go to anything. And so you know, oh no, it's a malicious link, but it's too late. And you've been owned. You know that your network now has been ransomed. And so this is what it looks like. This is how it comes in. And it happens to even good people who are trained not to click on random messages like this. So this is a scenario for you to consider. And there's all kinds of types of cyber attacks. You think of the wide surface of computing these days, and there's new technology, new features released all the time. And with supply chains, we're all globally linked now. And this is just a handful of types of cyber attacks. We haven't even put in things like social engineering, where you use your own person to lure people to give you information to go in and do an even more lethal attack. These are more where you're a little bit removed. I have 3 cats, by the way, which you might meet through the course of this presentation. Tomcat likes to advance the slides. So, this is where you can see with this very wide surface, it's very difficult for human security teams to keep up with these digital, pervasive, insistent types of attacks. There are some things, going back to our idea of why hasn't artificial intelligence been more effective in combating cybersecurity attacks. There are some things that machine learning and artificial intelligence excel in. It's like the human brain 100,000 times over. But there are also some things that humans are better at. And so that's where you have to understand how to train and what the limitations are of machine learning and artificial intelligence, and where I imagine then data scientists would also come into play with what you can cull out of your artificial intelligence from your machine learning and annotate up through an application or browser to be able to get the information and data that you need. So, the attack surface just grows phenomenally, constantly. And when we look at, once something gets that initial access, it might be through a service account on a system exposed to the internet that has languished. It's very difficult for administrators who run large global telecom or other type of manufacturing with enormous supply chains, where people are constantly having to update and provide information and invoices and other things to know all of the service accounts and manage the service accounts well. And it's incredibly expensive to have 2-factor or multi-factor authentication to service accounts that aren't user accounts, yes, but service accounts languish. So that's frequently a source of how the malicious software gets a foothold into network systems. And so you can see here, if it's not coming in through like a phishing attack from an engineering workstation, like we know Colonial Pipeline and some of the other devastating ransomware attacks came in, they look for a way to gain persistence. And so they're designed to go to Windows workstations, and they are designed to look, like legitimate files. And so when I was, I didn't introduce myself, but I've been in security for 30 years. I started out as a tech support engineer. I was a radio engineer, and I had been working with computing systems since I was 15, setting them up at the University of Washington after high school. And a friend came over to King Radio, where I was working as a studio engineer, and said, I was downloading to a Weiss database, and he said, you should be working with real computers. You should come interview at my company. And I did, and came in through tech support. And so I supported the top 2,000 companies around the world with technical support. We made applications and networking software in 1992. So one of the companies was a huge manufacturer, and they were going from LANs to wide area networks, and they were concerned about their intellectual property. And so I went to one of the engineers there that I knew, and he took the MIT Kerberos code, rewrote 85% of it, and we had a client encryption piece of software called Reflection Secure. And so our 2-person security company grew to 8 people. And, you know, a lot of us in security, we tend to be introverts, and we tend to like to analyze and study. And so, you know, the 7 men kind of pushed me out to go and talk about our encryption client and help marketing sell it, essentially. And it was an amazing opportunity. I went into places that I'd only heard about, and I had the incredible advantage of being able to meet and talk to people about what we were designing and developing. And I was hooked, you know, because I really felt like I was doing something important and helping people protect their information. But it only worked in the Unix environment. And so it was very much a niche product. And I did that for 7 years. And then I went on, you know, I was a risk manager for Western Mutual. I ran their InfoSec program. I ran my own company right when HIPAA and PCI and Sarbanes-Oxley came out. And I worked for US companies acquiring operations overseas. And so it enabled me to travel to 35 different companies and assess the operations against these emerging standards, security standards, so that, you know, they could fold into US companies easier. And so, you know, you do this and it's just thrilling work. And you can just always change and evolve. And you wake up every morning curious and wanting to do more. So, you know, this is where I was learning and seeing how the attackers were getting into all of these different companies, all of these different organizations. I became a chief security officer in 2010. I was DocuSign's first chief security officer. And then I was chief security officer at other companies. And now I'm a chief intelligence officer at a small tech startup that we're actually going to look at through this presentation. So I'm at the top of my career. I'm extremely happy because I work with a team of people that I do my best work with. And that's what I want to urge all of you to get to, you know, to find that company, to find that place where you are just embraced for what you do and what you bring to the table, and that your work works really well with everybody else's work, and you're creating and developing and making the company successful with what you do together. And so I'm actually working on my doctorate at an advanced stage, not because I need to for my career, but out of a genuine desire to learn more and to teach machine learning and artificial intelligence for cybersecurity to others in the security industry and beyond, to executives, to auditors, to compliance people. So that's the whole purpose of this presentation and sharing my research with you. Now, if you have any questions, feel free to put them in chat and Brian can bring them forward to me because all I see is my slide right now. Or we can wait to the end of the presentation, whatever you prefer. But I just want you to know I collaborate well, and however you want to ask questions well. So the whole point of this slide is to show you that kill chain of the stages where that comes into the network and how the malicious software will move, an example of where it will move to try and gain persistence so that it can enact itself and then impact in a way. Now, most of the time, they want money now. And so that's where ransomware is really coming in. But they will also disrupt operations. They will take places offline. They will, there is the fear that they're going to hurt operational technology that, mixes things together. And so if that's mixed wrong, it ruins the product. There's all kinds of ways that cyber attacks can really harm people. And so that's why it's so important for us to look at what could happen, look at these scenarios, look at the weaknesses, and figure out how we can use machine learning and artificial intelligence to quickly detect what is actually an attack in progress, not what's a vulnerability on the network. There's a lot of tools that already do that. What is actually like this, something happening on the network and is making these movements that is ultimately, as we see in the last impact here, going to disable and cause a major safety incident, take a place offline and cause a major financial impact. That's major harm. And so, we look at the cost of this too. Some of this is just really devastating, and, we're the good guys. And so we want to get ahead of the bad guys. And it's just something either you really want to do, that you wake up every morning wanting to do and contributing to that. When you look at a lot of research, because a lot of pursuing your own problem that you want to go in and research for a doctorate, ultimately, is you have to come into a doctorate program with a problem that you want to solve already. You don't go in and think about, you have to come in to get into a doctorate program. You have to think of a problem. And so I'm doing research on this, and, it's very difficult in security to find a problem because there are so many problems. Like even this, I thought this was funny. People think that there's too many words for cybersecurity problems. Should we call it information security? Should we call it data security? Should we call it cybersecurity? People are hung up on the verbiage. And I thought that was funny. It has nothing to do with stopping attacks. They're just concerned. They think the problem is what to call it. And so I threw this slide in because I thought in my research that was kind of funny. I use the names interchangeably. I don't care. It's not a problem to me. This is a problem at the organizations we work for. Now, a lot of us in security, we don't immediately think of money, but top executives do. Like my CEO and I work in hand. And so where I work with security metrics, he thinks in terms of financial metrics and financial risk, because he worked in Wall Street and he started 7 companies. And so it's a really good blend of the two of us. My CTO, who devised our algorithms for machine learning, and Tommy, would you do me a favor? Thank you. Give me just a sec here, guys. There we go. 20 years ago, my CTO was devising the algorithms for predictive shopping. Oh, you liked this? Maybe you would like to buy this. So he was doing that 23 years ago. He's just very brilliant. He's a mathematician. He understands algorithms really well. And, the 3 of us got together, along with our director of operations, who's worked with them for 20 years. And we were thinking of our own problems. So when we look at this total cost, this is what the CEO our CEO was looking at was this cost. And, you know, whether it's a malicious attack, whether it's a misconfiguration, a system glitch, whether it's human error, all of us make it, there's a cost factor to it. And so if we look, this is 2020, it's pretty much the same for what they pulled for 2021. You know, it's usually going up. You know, we see in the US, there's lots of opportunity here to have a positive impact. You know, we look at the Middle East, we look at our neighbors to the north, you know, we look at all of our friends here, everybody's struggling with the cost of data breaches. And it's just extraordinary that they're still happening. And a lot of the data breaches are caused by a lot of the same vulnerabilities. And if you had told me that 30 years ago, security would evolve to chasing after vendor patch problems and things of that, I would have thought it was an incredibly boring job. You know, I don't want to run after what vendors haven't done or what they've done wrong. I want to be involved in making sure things are locked down tight, and that that we're smarter than people trying to infiltrate us. And so that always involves a team, which I come from a big family. I have 6 brothers and 2 sisters and 15, 16 nieces and nephews. So, you know, I work best with a group of people who all come together and ask the right questions, and then we do the math, essentially. So this is the problem in a nutshell for my doctorate. We know cybercrime is just growing at this exponential rate. We know that, you know, who would have thought the bad guys would just proliferate in the way that they are, but they are. And now that ransomware they've monetized it through ransomware, they're going to keep coming and get that money. What really worries me is that the ones I love, their personally identifiable information gets out there and in the hands of the bad actors who will try to exploit them and their PII. And so we know that there's a growing skills shortage gap, and that's why I embrace all of you who are listening to this. We really do need to mentor and train more people on how to be effective quickly within the industry, first with that educational foundation so that you feel grounded and knowledgeable, but then also that you have mentors who can help you when you're there and have to act quickly. And again, there's just some things that humans are never going to be able to do as well as technology. And to date, the security technology has failed us in, you know, we're reading logs, we're chasing vendor patches, we're trying to correlate events, and it's a lot of work. And security actually used to be fun. And one of my goals is to make security fun again. So what's the significance of the research? Well, we know that cyber breaches are catastrophic right now, and they're costing so much, and that insurance gets reflected down on all of us when those ransomware payouts happen. And we look at the internet crime and the billions lost, and we know that they're monetizing our own personal information, that's out there, and that bothers me. And there's, at the date that I was doing this research, there were 4 million global cybersecurity roles when you counted audit and compliance in there. And so we need to train adequate talent. And I firmly believe I'm an example of someone who stepped into security, and I was told not to. I was told no one wants to talk about security, you know, no one will pay for it. And I was actually encouraged to get out of it. And I'm just glad that I didn't listen to that boss in particular, because I was going out to these incredible places, learning about their business and what they needed to protect. and I want it to be a part of that. So we know security moves at the speed of business, and it's always a moving target with new technology coming in and new business starting. And so we know we need better methods, tools, and services. And so, Evie, if you will, there you go. We look now at the old security colliding with the emergence of what we know about machine learning and artificial intelligence. So why hasn't it been effective? Well, let's look at where it has been effective. It has been so incredibly effective in so many areas. You know, with natural language processing here on the right, we know that all the chat bots and other help mechanisms for online learning, especially, it really has advanced quickly. And that's been a major help. So that's moved into the knowledge engineering space, where it's able to return information quickly based on keyword queries and things. We know that neural networks, which I worked with 20 years ago in order to combat credit card fraud, we had a 50% fraud rate on this one portal for credit cards. And we used neural trained technology to feed it bad transactions versus good transactions. And we cut down fraud with credit cards to 1%. And so we know it can work, but it took a lot of feeding and training at the time. And that was something that people were still trying to understand how to do well 20 years ago. And you could buy essentially the seed for if you were a financial institution, you could buy the neural seed to train something financial or something retail. So you had a place that's no longer a business, unfortunately, where you could start that and then custom develop that to your own business based on what industry that it was built for. You know, we look at deep learning, which has helped and is very specific. But where we found that deep learning wasn't appropriate for artificial intelligence for cybersecurity is that it took up too much bandwidth. And when you have organizations who might do rapid financial transactions, think of the stock market, think of gaming, something that's doing these really dynamic postings, that takes up a lot of bandwidth and there's a lot of traffic. And so that's where artificial intelligence and machine learning have struggled. It takes it in itself, you've had to be able to have it scale. And the models for machine learning to pass along, to do the work, to learn, and then to pass that to artificial intelligence to bring up to the surface, to the humans, to validate. It wasn't able to keep up with the scale, and thus it wasn't able to really find the needle in the haystack or the needles in the haystack and keep up with it. So even just 3-4 years ago, I was talking to chief security officers who went after some of the newer AI security tools and invested in them and had high hopes. And then they found out that they helped a lot and they returned more data, but it wasn't what they thought. It didn't return as much as they thought. They were still stuck with false positives and false negatives from Victoria Gonzalez. Let me shut her off for a second. Sorry, I'm trying to buy some land, and that's my real estate agent. So that in a nutshell is why machine learning and artificial intelligence has been a struggle for AI. It's how do you train the machine learning to pass to AI for these dynamic networks. So let's talk about this. So when you go out and you do your research study, you have to have participants. And I do a mixed method survey, which means that it has to have statistical significance. And that means I have to have at least 60 participants as part of my research design. And when you look at the different designs, you can do like you can go and do case studies. You can do different ways of interrogating people's experiences and all of that. You can do surveys, you can do all types of ways. But once you design your research study, you have a way of coding it, of looking at what's being returned as to whether the problem that you're trying to solve for your study, whether your hypothesis is going to be proven by the study or not. And so from that, then you get these conceptual categories from it. And, you know, you do your comparisons and then you deduce and your many theories from it. So the whole process to me, I feel makes me a better professional, a better working professional, a better presenter, a better tester, because I look at the research and what others have done and have tried with machine learning and artificial intelligence for cybersecurity. And then we're trying to do something different. We're a tech startup company. We came together in 2017. We looked at what was wrong with machine learning and artificial intelligence for cybersecurity. And so the first thing we knew we needed to do was solve the noise at scale problem for busy networks. And so the impact of the study that I was focusing on while our CTO was solving that problem with some math and some algorithms was going back to the idea of coalescing as a team, because I wanted our ML and AI to do a lot of the drudge work that security teams are doing, looking at logs, trying to correlate events, running after false positives, worried about the false negatives that the tools weren't alerting them to. You know, I wanted more of a war room where we all sat and thought, how could people attack us? And spending our time thinking at a higher, more educated level, like the hackers have time to do. They're buying code off the darknet already that has been successful elsewhere, and they're reusing it. They have the luxury of more advanced attacks and a way of getting it. And so they're not running after all the drudge work that security teams are doing. The second thing is obtaining management support. You want to work for a company that supports you in your role. You don't want a bait and switch where they hire you to protect the organization and then give you other work to do so you can't fulfill the basics that you want to do, which is protect the organization and make sure it's not being attacked, because no security person wants to work at a company that all of a sudden has a massive attack announced, because it makes you feel like you weren't effective at your job. And so that's another reason to get ahead of it. I mean, I've been very fortunate in my career that I eat, sleep, and dream security. And every morning I wake up thinking, what could have fallen through the cracks that I haven't thought of? What do I need to look at? What do I, what haven't I missed? Even as a CISO, I was looking at log alerts. I'd come in the morning. I knew even more than my director of operations what the problems were, because I ran the audits, both the internal and external audits, and I passed every single one of them without a minor or a major finding. 3 years at DocuSign, I got, ISO 27 certified, PCI DSS, pen tested, not a single finding, minor or major, in those 3 years. Not because we didn't have them, but because, I drove our team exhaustively to just think what could go wrong. And the tools we invested in helped, but it really was our brain power thinking of what the tools were missing. and then finding that before the auditors came on site and fixing it. And we didn't always have management support. I remember I left one job because I was being forced to pay for downtown parking when incidents were happening, and that's very expensive. And I wasn't paid that much. And I thought, well, you know your value if they want you to take on the cost of managing incidents for them, and they're unwilling to reimburse that. So that's what I mean by obtaining management support. Will they help you invest in the right tools so you can be more effective in your job protecting the company? You'll find out pretty quickly when you do. Is your team there? Is your team all in? Is your management all in? Because no one can do it alone. And ultimately, it's your reputation and career on the line. And then you want reliable technology. You want technology partners who are not going to let you down, and they're not going to give you technology that they're not going to train you in. They're not going to charge you to train you in. They're not going to not patch their stuff. If something is buggy, they address it ASAP. What I care about is having a UI that every single role, whether you're an executive, whether you're a director of cloud security, whether you're a data scientist looking for certain data to come up on what the AI is detecting, the anomalies and the confirmed incidents that the humans are validating. That's the kind of technology and the UI. I want to walk in every morning and see exactly what I want to see, not what the vendor has just put together, but seriously what I want to see. And I know everybody else does too. If it's an auditor, I know they want to see exactly what's been audited and what's still to be audited, and how empirical data was pulled from a tool and returned as to what the state of the control activity was, what it proved out. So I anticipate that we incubated our machine learning and AI. We did not use supervised learning. And when you do your research on machine learning and AI, you'll find that there's supervised learning, where basically, just like neural networking 20 years ago, you show it what malicious attacks are. It's not much different than just antivirus, anti-malware signatures. That's old now, and that can change easily with a few bits being changed. So supervised models are easy to defeat. Now, you want a database of supervised models so that it's easy to detect, but you really want machine learning that's also going to learn on its own in an unsupervised or a hybrid way so that it can learn itself. And you want that reinforced so that it's accurate in detecting what's malicious. And the great thing about our service, so we not only have this behavioral analysis that detects suspicious behavior from anything that generates an electrical charge on the network, no matter how briefly. It does a baseline, and then when there's deviations, that's reported as an anomaly. And as it keeps analyzing it, it moves it either to an incident for a human to verify that it's an active attack in seconds, or it keeps it, sometimes it's an IoT device that is, inappropriately just scanning, for other IoT devices. So, when you just start with us, you'll find, like if you put it in your home or something, you'll find IoT behaving very badly. It's really doing things the device never should do. Why the vendors did it that way, that's going to be another conversation. But once you start understanding what you're installing is doing based on its behavior, you can understand why tools, other just tools that look for just malicious, not just behavior, but just only malicious behavior fail. So when you select your criteria as a security person or a data scientist or an auditor or a compliance person, you know, you really have to put this forward to management. And the first thing is the cost. You're going to have to justify the cost. So the tool and the live monitoring service, it can't be expensive. It can't be one of these, you know, $1 million a year tools, because you won't be able to get it in quickly and easily. So you need something that's going to be cost effective. And that's why working with emerging vendors helps. Resiliency. So we know that especially with OT environments, they can't change very much. And a lot of the attacks that come into operational technology environments, that, you know, gas and oil and manufacturing and SCADA networks, it comes in through the weaknesses from the IT environment, from the malware and phishing attacks that come in that way. And so, you know, the resiliency of some networks, it just has to, they can't be patched. They can't upgrade the software. They have to be resilient, and they have to be able to have security tools that detect and support a certain level of resiliency and confirm that level constantly. And then, you know, the tough part is the political buy-in. Not only do you have to get the management buy-in, but you have to get your team's buy-in. And let's face it, when you work with people, everyone's going to have their favorite vendors. And I used to do things very democratically. I used to tell people, do your research, pick your own tools, come to me, you know, give me 2 or 3 that you've researched that you think we should invest in. And, you know, we would buy them, and then they would find the problems with it. And I would be back to finding myself looking at logs as a CISO because they didn't like the tool that we had invested in. So don't be afraid to not do things democratically all the time, to do an executive decision based on what you know from experience. So it's not just management, it's your team, it's good people who believe in a vendor, but the vendor isn't owning the relationship themselves. And then really it's the sustainability. It's amazing how many companies who have a healthy security budget have put things in and ripped them out within a year because they didn't do what they needed to do. And so you really want to look at the life cycle of your security investment to grow as a security team and really be taken seriously, not only within your own organization, but across divisions and within the industry. So when CISOs and intelligence officers and all of us get together and talk, this is kind of the cycle that we talk about when, you know, we talk about whether technology worked for us or whether it failed, and why we're approaching, why we're building and designing new technology, keeping this in mind. And so you do the trade-offs. And Brian, how am I doing on time?
Joan, you have about 3 more minutes.
Okay. So let me just go through these slides quickly. You do your pros and cons through your criteria, because everyone's going to look at what you're going to invest in. And, you know, you look at everything from CapEx to how much engineering cycles it's going to take to narrow down your investment. And anywhere where you're working at should have an AI vision. If it's not already in place, you should help them move to it. And so I think, yeah, this is my last slide. So what behavioral analysis with continued managed monitoring does, and this is what you can do for me, gang, you can help me convince others to try the technology for research purposes right now. So upon installation, it reports anomalies, suspicious devices, and activities. So one of the things that we do very quickly is that we detect misconfigured devices, or we detect rogue devices that start up and then stop. They have strange on-off behaviors. We detect malware. We detect 0 days where nobody knows what kind of malware it is. They just, take it off and put it in a sandbox, and then we figure out what kind of 0-day it is. Because we take baselines of all devices, applications, and thus it ends up user activities when you turn things on, turn things off. And so what machine learning and AI is really good at, and I don't care if you have hundreds of thousands of devices, this is what machine learning and AI, if you do the modeling correctly, it can take all of that in and digest it all. Right? It's not taking in every bit of data in terms of the bits and digits. It's taking digest of what's important across the network and the applications and the north to south and east and west traffic. And it just innately is trained to detect what's suspicious, and with a high degree of accuracy, with a very low false positive rate. It's so exciting when you see something designed really well that's been incubated. Because we didn't rush to market, we didn't need to. We all invested it in ourselves. We didn't go out for venture capital. We just all funded this ourselves after long decades in the industry, and we did it right. We wanted to make sure. And so the idea is what I call killing the kill chain. That's what I'm writing about right now, so that we want to detect it early when it comes into the environment, ideally as it gains the foothold or when it moves from the foothold. We want to detect that. And so, it'll come up as an anomaly, and we'll confirm it as an incident. And right then our live monitoring escalates it. So, if a place already has a SOC, the great thing about it is we can be a secondary SOC and give your team time off. So you can actually have vacations and weekends, and feel like you're in good hands, that you don't always have to be on 24/7. But the great thing about it is we have playbooks for what it is and how to contain it immediately. And that's the educational part about it. And that's where internships are going to happen with our company, and where we're going to grow, and really exciting things are going to happen. You're going to be exposed to attack patterns and behaviors that are very sophisticated, that you're not going to see from tools that are currently on the market, and that don't train machine learning and AI, that don't incubate it and let it learn itself. And so this idea of unsupervised and hybrid patterns, it really is great with highly dimensional data that tries subterfuge and does polymorphous attacks where it has multiple attack vectors. And so it tries diversionary attacks, and then it performs well in high transactional sites. So that's my research based on our own development. And so I'm going to prove whether the technology that we've developed and we're just releasing to market now is as good as I think it is. So you can help me try and put it in at no cost and just test out for my research. And that is some of the basis of my research. I didn't put all of it in because I didn't want to give my doctorate away yet, the exact research and study, but as it comes along, I'll share more with you, I promise. Okay.
Yep, we need to questions.
Thank you very much, Joan, for your excellent talk today. It was very insightful, especially for students who are interested in AI, with the intersection with cybersecurity. And I wonder if there's any question from the students. I do have one question, Joan. I really enjoyed the talk. For example, for the students who want to pursue an intersection of AI, machine learning, and cybersecurity, what would be the recommended career path in terms of their education? So would you recommend them go through the route of cybersecurity or AI or machine learning field, and, get additional education in cybersecurity?
That's a really good question because, the way that I fell into it, I believe that if you really truly want to do AI for cybersecurity, you just keep that focus and bring that into your company because you will bring that along in a company. If that is your vision, don't detract from it. You bring that AI vision into the company and they might not have it. It might be even a year, but that gives you a year to study up on what you want to bring in, learn the business and bring it in. For example, what I'm doing, and this would work for internships as well, is for the people who are doing the proof of concepts, installing us, I'm training 3 people in the company on machine learning and AI, and I'm giving an Insight Cyber certificate that shows, and my CTO is teaching one of the courses. My CEO is teaching one of the courses. My director of operations is teaching I'm teaching. So we're all contributing to training people in it. And it's not a university level course. It's not an accredited certification, but darn it, we're going to train more people in because there's not enough of it. And, I know that when I tried to take industry courses in lead auditor for ISO 27001, I was really disappointed in it. And it costs like $2,500 too. And that's where it's like, no, if you just do a POC, we'll train you and give you the certificate for no cost. And because I just think this whole thing of monetizing to protect information and keep people safe, it's just been monetized too much. And I really feel that after this lovely career in it, I just want to give back without the expectation of charging for it. And so that's where I mentor. That's where Morgan and I talk about, how can we help with a lot of city university programs? How can we bring K through 12 teachers in and show them what city university is doing and expose them to businesses here that do it? We have to have more programs that enable people to come in. So there are some sites, and if people are interested, what I'll try and do is dig up some sites and see if I can't put something together for a little bit of online looking around and just stuff that you can find. My own research, I have right now about 30 different reference articles. So you just go to Google Scholar, and if you put in data science, machine learning, and AI, and then even another topic specific to what you want to draw out from your data science viewpoint, your perspective on a study, you'll get these articles and you'll pull out your own 25, 30, and you'll see what they studied way down. You have to really narrow your study down to be successful. And so you won't find, you'll see where you can contribute to the academic industry as well with your own research study by going on and doing a master's level study, by doing a doctorate level in it, and then coming along and learning, because I believe in always learning, and that's why at my age doing a doctorate, I'm just doing it for fun, because it also just helps me learn more. And I work with brilliant people, and I like bringing things to them to contemplate too. And so a lot of the AI research papers are just fascinating, and you should read them. And a lot of them have statistical significance, and look at how they did their study and how they tested it out. And they had to build their own models, and they did it for something very specific, and sometimes it failed. And so really go to Google Scholar, read all you can, think of your own study and model your study just as if you were going through an academic course. In your work, try to think about how you would apply machine learning and AI to take away some of the drudgery. And then if it isn't out there, think of how you would I want to start, you know, my CEO and I, we always say we're going to start 2 to 3 more businesses after this one. You know, become an entrepreneur, you know, think about how you can design and build based on what you know, because you're going to have long, successful careers as well. And you're going to find great people to work and partner with. And you'll find investment money if that's what you need, or else that's where you'll also, you know, that's the way actually to build wealth as well.
Thank you very much. Yep.
I
So-
know it's very difficult to ask questions in this type of forum. That's why please feel free to give my Gmail address out. If you know, I'm more than happy to continue the conversation with anyone interested.
So one thing I would like to mention, because this is a question I've been wanting to ask, and of course Angela would ask this, I really appreciate this, is when and how can people apply for the internship? Will you prefer cybersecurity students or anyone who is willing to learn AI, ML?
Yes.
And Angela's not the only one that's asking this question.
Well, the immediate one is my chief security officer. He is standing up the live monitoring site. And so his passion is taking people and having these internships so that they're going to take what's coming from the AI and validate it. And he's interested especially in people of color and women, and really because he's a person of color, you know, so there's going to be incredible opportunities. Right now, we're a small startup and we're just launching to market. I expect us to grow very quickly and have a need for internships and very soon paid internships. So Morgan's going to be the point person. So I'm throwing that back to you, girl.
Yes, I was going to be voluntold to do this anyway, and I would have volunteered. And the thing that you're pointing out, Joan, is how quickly the industry and the field is changing, because there was a time when, do you remember back in like the 2000s, the average day to finding that you had been breached was like 220 days.
Gosh.
Remember those days? And then they started coming down, and now you can actually catch them in the process.
Yes. Yes.
Because of the technology that you are developing.
That is making security fun again. You nailed it, Morgan. Thank you.
You're welcome. It's just very frustrating always getting beaten up and never winning against the bad guys.
And would it be great to get City University credit for the internship too? I wonder what I would have to go through for that.
Joan, we have it all set. You and I have got to get together. We've got the internship structure. We are we're just waiting for the company to appear and the students to start raising their hand and saying, I want to participate.
Well, you better hurry because these girls are lining up.
Yes, they are.
Yes.
You know, one of the things that we generally do, Brian, is you have everybody come on camera just for a final shot. If we could do that. You know.
Sorry, I was muted. Yeah, thank you everyone being until it's 5:40. Thank you for staying. So let's have what is it?
Yeah, take if
Together,
you have
together
a camera.
mode. Yes.
If you have a
Yeah.
camera.
Yeah, if you have a camera, would you turn it on?
And by the way, our cybersecurity club meeting is running late and I'm getting close to laryngitis. So I'm supposed to present today. We could probably turn this part off now. So Joan, we're going to have you coming to cybersecurity club too. And everyone is always welcome. Come on, we got to see a couple more people. JC, I see you there. Joan, you could take your camera. Ollie. There were 13 people on here and I'm only seeing 4 faces. Maybe my screen is too small.
Did she see me?
Come on, Angela. I know that you're there. You're not coming through your background. Always trying to leave you. Hi, Kim.
Hello again. Hi, everyone.
You better get Ollie's picture in there because otherwise you've changed names. I guess this is the best we're going to do there. Angela, turn off your background. It's keeping okay. Somebody, Kim could still be in the picture. There, that's it. Somebody quick, take a screenshot.
I did. I got several.
Oh, you got it.
I
Great.
got several. I got several.
Oh,
Great.
you're on
Thank
the-
you. Yeah.
I just want to thank all of you. You know, there's one other thing I want to say to the people that have shown up here. For this core of people, I encourage you to ask your classmates, tell them what they are missing. Because between Joan and I, we started talking about our network today. There are so many people that we know that, in fact, I just heard from the I think he's the CISO, maybe not of the ORCA system. And he was complaining to me about he cannot find good risk management people. He's very disappointed and wants to develop a program like this. So start showing up to these clubs because then we know that you're going to follow through for us and go that extra mile.
By the way, our service also has a risk register, security metrics, little things like that in it.
All those little things. Brian, this is your show.
Yep. Thank you everyone for being here today. And Joanne, we really appreciate for your insights and your knowledge. And I'm pretty sure you touched hearts of many people who are here today. Thank you very much. And thank you to your lovely nephew who has been staying for very quietly and very gently. Very adorable.
Okay.
Thank you.
Thank you.
Denise.
Thank you.
Bye. Thank you.